Hi. In this section, we're going to look at using the limit laws to calculate limits. Um, I want to go over the limit laws individually, but we're going to wind up using them as sort of a corollary to all these limit laws. Actually, the fact down here at the bottom. But let's look at what the limit laws say. They say that suppose c is a constant and these limits both exist. It's the limit of f of x and g of x as x goes to the same number a. This first thing says that if we take the limit as x goes to a of the sum of those functions, we can do that by just taking the sum of the limits as x goes to a. And the other rules tell us pretty much the same stuff. If we're subtracting the functions, we can just take the limits independently and subtract. Same thing if we're multiplying them or if we're dividing them. Only additional thing is, of course, we can't divide by 0, so that's why we have this additional condition. So if you put all of this together, we get something nice. It's the fact that if f of x is a polynomial function, a rational function, or a square root function, and really this applies to more functions than just these, but if f of x is one of these types of functions and a is in the domain, we can just plug a in order to get the limit. This is called the direct substitution rule. Now, if you look in the textbook, they go through a lot of examples where they painstakingly go through and evaluate a limit. Well, let me give you an example. Like right here, I'm calling these really easy examples. The book shows how to do this and painstakingly go through every application of the limit laws. But the direct substitution rule is really nice because this is a function, and 4 is in the domain. The only thing that's not in the domain of this function would be, negative 1/2? Or no, positive 1/2, because that would make the denominator 0. So for this function, we can evaluate this limit just by plugging the 4 in. So let's see, the top is 21, and the bottom is 7. So this limit's just 3. This next one also, we're approaching 3 from the left, and 3 is in the domain of this thing. So we can just plug it in. So it winds up being the square root of 16, which is 4. Now notice this approaching from the left didn't really matter because we're just plugging the number in. It's in the domain. So we really kind of ignore that. If this had been approaching from the right or if it had just been the overall limit, it'd be the exact same.